On this video, we have a lot of interesting things happening. Our green line is our green function, is our original function. Up here, it is ax cubed plus bx squared plus cx plus d. We have a, b, c, and d here, which will be moving and changing our graph. We have a graph of the line that is the tangent line to our function at the given point. We have m, which is going to be the slope of this line. Down here we have our point A, which is going to be a point on our function. We're going to move it around. And then we're also going to look at point D over here, which is a point on the derivative function, which is a parabola. It's an x squared. And the value of the slope of the line will be the value at D. It will be the y value at D. The x value will be the same as A. So if we look at where we move A, one point of interest is here. Our derivative is going to be close to 0. I don't have it exactly on the right point. Can't quite get there by sliding. But my derivative value, my slope of my line is close to 0. My D is 0. And the tangent and the derivative both there would be 0. The same is true down here at this point on our graph. If we get it as close to 0 as we can, and you see D moving it right about at the 0 point for the y value, because it will also be close to 0. Our slope is going to be close to 0, and the derivative is also going to be close to 0. So if you look at those values over here, the 0.03x, the 0.03, and the 0.03 are all three always going to be the same. In this case, they are actually very close to 0. When we move our A, you can see it expanding our upper value here. It's going up. When we expand our B, move it, it changes our graph a little bit, but notice our tangent stays the same, our parabola stays the same. Our C value moves our graph a little bit, but again our slope and our D value are the same. And then D, which is our constant value on the end, is of course just a translation. It has no multiplication factor times x, so it's just going to slide the graph up and down. But that does not change our slope at any given point. Is a translation, so it doesn't change shape. As we move our point up here, we're increasing our slope of our tangent line, also increasing our D value, which is the same as the slope. And as we increase it more and more, you can see the values of our slope rise over run, increasing. D is still moving up, and as we move up and up and up and closer to the top, okay, we lose our D up there at the top. But our values are still going to be the same. We're at 6.17, M is 6.17, and our D is at the Y value of D is 6.17. In between, we have a negative slope. So you see negative 2.69, our slope is negative 2.69, and here the slope of our line tangent is negative 2.69. This is actually the equation of the tangent line, the derivative, the slope of our tangent line, and the y value of our point D, which is moving along the parabola of our derivative. So as we move around, move A around on our function, we can see D moving. We can put a trace on D. And here we can put on object properties. We can show a trace of D, which will make it stand out quite a bit. It's going to be red. And now as we move A around on our function, you can see it where D moves along our parabola of our derivative function. So now that becomes red as we trace it around, and it makes our derivative function, our parabola, stand out even more. So a lot of very interesting things going on here.